This video is going to cover question 2, part A from the 2021 AP Calculus AB free response calculator required portion of the test. I cover sections A, B, C, and D in their own individual videos. So if you want to look for B, C, and D, those are going to be in separate videos from this one. All right, so let's see what we got here. So they want us to find the position of particles P and Q at time t equals 1. So particle P is the top particle here. It's moving along the x-axis, and its velocity is given by this equation here. And then importantly for us on this problem, at time 0, its initial position where it's starting from is given to us as 5. Then the second particle, particle Q, also moving along the x-axis, also given a velocity equation to work with, and also given a starting position to work with right here. What we need to do is we want to use an integral right now, an antiderivative, to determine the displacement of our particles from their initial position. And so to find displacement, displacement is the integral from A to B of whatever your velocity equation is. So for us right now, we're just going to have to do this twice because they want us to find it for each individual one. And what we would do is we would take and with our displacement, we would just add on to the front of it. This would be our initial position. So from that initial position, we could move forward, we could move backwards. They'll let us know, but we kind of put it all together to get our answer out here. So for particle P, let's set it up. Particle P started off with an initial position at time 0 of 5. So we're going to have 5 plus, and then we're going to do the integral from 0, and then we want to know how it displaced itself for 1 second or 1 time unit, whatever they're talking about here. So from 0 to 1, and then we use our velocity equation. So sine of t to the 1.5 dt. Great news is this is a calculator required section, so that integral there is not going to be rough on us. We're actually going to do that in the calculator. In y1 in the calculator, we're going to put our initial equation there, so the sine of, and we would call it x when we plug it into the graphing area, to the 1.5. We'll graph that, and then we'll go ahead and do a second calc, and we'll choose the number 7 option in there, which is integral of f of x dx. It'll then ask us a series of 2 questions. It's going to want to know the lower bound and the upper bound. We'll find out what those are, and that will give us at the bottom of the screen, it'll say integral of f of x dx. And whatever that is would be the answer to this first part of the problem for this piece right here. And then what we'll need to do is we'll need to take whatever that number is and add to it our initial position, and that's going to get us our final answer for where P ends up at the end of this. Then just setting it up at the same time, we could say what's going to happen with Q. Same idea here, right? The only difference is Q's initial position would be at 10. So we want to know when 10 plus, again, integral from 0 to 1, because we want to know what's happening in the first 1 second. Then we'll use the velocity equation for our Q function, which would be t minus 1.8 and then times 1.25 raised to the t dt. And then all you're going to do there is, again, this is the calculator section. So we're just going to take and we're going to pop that equation into y1. We'll clear out the other equation we have in there. We'll type in this equation. So t minus, well, we'll call it x when we plug it into the calculator. 1.8 times 1.25 to the x. We'll do like we did on the other one. We'll graph it. We'll then hit a second calc, and again, we'll choose that number 7 option, which is the integral of f of x dx. It'll ask us for our lower and upper bound again. We'll type those in, then we'll hit enter. It will give us out at the bottom of the screen, integral of f of x dx equals, and then from there, this time we're just going to add to it 10, because that was our initial position. And then whatever comes out of that is going to be where it got moved to. So pretty straightforward once you have the setups all in place. So we'll start with P first. So going with P into our y equals, we type in that equation. So sine of x, raise it to the 1.5. stay in radian mode, be in radian mode the entire test. Everything in the AP Calc test is in radian mode. So just put your calculator in radian mode and don't change it from there. So we'll shove that into Y1. We'll graph that. And now from there, we're just going to go to our calc menu. We'll hit second, calc, and inside the calc menu, we'll choose the number 7 option, which is integral of f of x dx. I hit enter on that. It wants to know at the bottom of the screen, it's asking me for the lower limit. The lower limit on this problem is 0, so I type in 0 and hit enter. It now wants the upper limit, so I type in the upper limit, which on this one would be 1, and I hit enter. It colors it in, and at the bottom of the screen, you can see that it's giving me the integral of f of x dx equals 0.370660. And so on the AP Calc test, they really kind of like you to take it out to 6 decimal places before you would add it and to the answer. I mean, on this one, it's kind of weird. You wouldn't have to worry too much about it because you're just adding it to 5. So 0.370660. So that's what they want you to take it to there. And then when you add those two things together, you would just go ahead and get out. They want the final answer would be in 3 decimal points. And so for the AP Calc test, 6 decimal points before your final answer, usually 3 decimal points when you get to your final answer. So then that 6 behind the 0 would tell us to round that to a 1. So we'd be looking at 5.371 for the position of P. And now we're just going to do the exact same thing again when we come to do the next problem. And so we open up the calculator, go to our y equals. In these situations where you think you might want to use that same equation again, you can turn equations on and off so you don't have to retype them by just scrolling your cursor on top of that equals sign and hitting enter. So you'll notice now that that equals sign went from being highlighted, which means it's turned on, to being not highlighted, which means it's turned off. So you might want to do this. It could save you some time for typing problems in multiple times, typing equations in multiple times. So from here, I'm now going to use the Q equation. So that would be x minus 1.8, close that, and then 1.25, raise it to the x. When I go to graph this now, you'll see that it just graphs that one equation. So I don't have to worry about the other equation. But in case I need it for parts B, C, or D, it's already in the calculator and I don't have to retype it. So now I'll go through and I will again hit second, calc, and then we will choose the number 7 option, integral of f of x dx. Wants my lower limit again. The lower limit is 0. Type in 0, hit enter. At the bottom of the screen, it's now going to ask me for the upper limit. The upper limit is 1. Type that in, hit enter. And again, at the bottom of the screen, I see integral of f of x dx equals, and this time you can see that it went negative. It's actually moving backwards from where it started from. But take it out to 6 decimal places when you first get it before you add it to 10. So negative 1.435645. So negative 1.435, was that 435,645. And now we're just going to add that to 10. So go back to the normal screen and you would say negative 1.435645, add 10 to that. And then for your final answer, go ahead and put that to 3 decimal places. So the position of Q now would be 8.564. So it actually moved backwards from where it started from, but that would be the position of Q. And then as you think through this one, this question here would have been worth 3 points to us out of our total 9 for question 2. And so we're going to get 1 point for getting our definite integrals all set up. It counts as both of them. It's kind of like half a point for each, but they only give you, so you get them both right, so you get a point for both of them. Then from there, you end up with getting your final answers out. If you get one answer out, you get another point right there. You get the second answer out, you get another point right there for a total of 3 points. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.